All right, this is another way of looking at that just laid out flat, which is how it would be represented in a book. So we can take a look at this, and we have again, 0 to 1 if you want to say that. It's not the entire thing, but it's 0. How much is this line right here? 0.025. 0.1, okay. 0.125. 150, 175, 0.2. All right, so what does this particular micrometer right here read?
0.2262.
All right, so we've got 0.2. How many 2.5s do we have?
One.
Say 0.025. This counts for how much? How many? How many does the thimble?
0.001.
Now, what's the increments?
Oh.
Tens, thousands? Thousands. How many thousands do we have?
1.
1.001, because we're going to be reading on this line all the time. So what it lined up there, it's right there. So that's a little more than 1. And so now we have, you can guess, probably about 0.2, but we can look up here. Go, which line lines up? This one? Nope. That one? That lines up. There. So we're going to do a 6 or we're going to use a 2? 2. Why else would they put numbers over here? Because we already have numbers over here, so we're going to ignore the ones over here. We're going to use one over here. 0.002?
No.
0.002. So for me, the easiest place for me to start when I'm doing something like this, if I don't remember, is to look at the thimble. Okay, the part that goes around, and that part here that goes around goes up to how many? What's the highest number?
24.
Right here on these. 1, 2, 3, 4, 5, 6, 7, 8. How many lines are there? Not on this, on the actual micrometer.
On the actual micrometer, it goes up to 24.
How many lines are there?
25.
25 lines, 24 numbers. Including, if you count 0, 25 numbers.
I do count 0.
And 25 numbers.
So this is the thimble, the part that goes around. It has how many lines on it?
25.
25. That's 25 lines. So right here it goes all the way up to 25. And so each one of those is how much? 0.001. And it goes all the way, and it goes around one time. And if it goes around one time, it's going to end up right there, isn't it?
Yes, sir.
So, which is right here is where I'm showing you. So each one of those is 0.001. If it goes around one time, it's going to end up on this line, which is right there, which is 0.025. No wonder you can't figure that. 0.025, yeah?
Yep.
So I kind of start there and work my way up. I could have started there, but I think it made more sense now. So then I go around one more time, 25 of these lines on the thimble, and I'm going to get to 0.050. I go around one more time, which is 25 lines, and I'm going to end up over here, which is 0.075. So there's a pattern. Yes.
When we're looking at like when we're writing it down, so when we get to that 0.050 mark, do we have to have that trailing 0 at the end, or can we just write down 0.05?
You're at 0.05 if you like. I don't care. You can see how I instinctively do it without thinking. That's how I write it. I don't. So if you want to write 0.5, that's fine. I feel like, and this is just me, all right? So I always tell you when it's just a me thing. I feel like 0.50 or carrying it out 3 digits is more appropriate in aviation because it tells somebody you didn't round, that you actually did that.
Okay.
But then you could argue, well, did you round the 10,000s? So, but then I feel like it's being a little too much to do that, but you can do that. So that's how you want to do it. Remember, when you're writing stuff down and you're measuring stuff on aircraft, this becomes part of a permanent record usually. You don't want to just measure something and do you imagine if I was building an engine, or anybody, and you're building an engine and you're all done and the boss comes in and goes, well, did you measure the engine? And you guys are going to measure an engine in 310, and it will take you literally 1 week to measure the whole engine. So at the end of 1 week, I come up to you and say, all right, did you guys measure the engine? Yes, we did. How did it measure? Good. Where's your measurements? Oh, we didn't write them down. We just did it, and as they were good, we just kept moving. They're good. So that's an A, right? Yeah, it didn't work that way in aviation. Everything is documented, written down, part of the records. When I was working in the engine shop, somebody else did the measurements. I'm like, let me see your measurements. Let me verify them. Oh, I didn't really write them down, Kev. Well, then you're really going to do it again. So, yeah, that doesn't work. So we write everything down. Becomes part of a record. So, all right. Micrometers do have dual uses. This is the best use right there. It's a calibrated vice grip. So be gentle with them. See, that's a joke right there. It's like, but if you're going to do that, you got to get them tight. So you got to put a vice grip on the end. Okay, so that is the outside micrometer. And they're in 1 inch increments, so you got to get the right one. If you're measuring something that's 2.125 inches, which micrometer do you need?
1 to 2 inch micrometer.
Nope. So if it's 2.125, I need a 2 to 3 inch micrometer. Don't forget to write the 2 on the beginning. We often measure, well, we have to measure especially engines. Remember, I always think engines. Measure the outside diameter of something, and then we have to measure the inside of the diameter of something that may go around it. So we have to measure the inside diameter. There are several ways to measure the inside diameter of something. My favorite way, and the appropriate way, would be to use an inside micrometer. Inside micrometers, I don't think I have, yep, that's all I got. Okay, inside micrometers. Once you know how to read an outside micrometer, you can read an inside micrometer. How much does this one read? You don't know because I just changed. I'm trying to get on the magnifying glass. There we go. What does that one read?
0.275.
Got, right, we got the point. I can't write because I'm here. 0.2. We have 1, 2, 3 line. You can't see that line, but it's on 0, and it's a long way from this middle one. That means it's on the 2.5, so it's 50 plus another 25, however you want to look at it. So that's 0.275. Now the problem with these becomes the whole setup on it, and you have to be very careful with it, because that would be fine if I had it like this. They have it in the picture, and that would be you have to be, okay, the point of, you have to be careful because that's more than an inch. That looks like a little more than an inch to me. Let me see, if I put that on the same thing, boy, this one's stiff. 0.2, there we go, 0.275. I have this one matching that one. So is that 0.0? 0.275? Here's a 0, is that 1 inch? Nope. Here's 2 to 3. Is it 1.275?
2.275.
It looks to be about 2.275. So that's about as small as you're going to measure as a 0.2, just because it takes some mechanism to get in there. When in doubt, you can do just what I did. Grab your inside micrometer, grab your outside micrometer, place it in there very carefully, put it in there, roll it down, and I got, this is how you calibrate it. They're not the same. They're very close, but they're off. Oh, it's because I twisted it. It's off by about 1/1000. So, half a thou. Oh, I say that a lot. Half a thou. How much is that? 0.0005. So yeah, 5/10,000. So half a thou is what I say. So yeah, so you can turn it around and measure it like that, when in doubt.
Does it have a lock as well?
No, doesn't have a lock, and you get into where you start adding extensions to it. So if you're using these, be very careful not to lose the pieces that come out of it. and never ever put a piece that comes out of it a quarter of the way out and like squish it down and go, now it fits. All right, example. You're trying to measure a hole and you've got this all the way screwed out and it's still just a little bit, the hole's too big. So you unscrew this right here and you pull that out a little bit and tighten that up. Yeah?
No.
Don't ever do that. It's number one, it's like then what are you measuring? Don't do that. But they do come with spacers that add a 0.5. So you can take this out, add the calibrated 0.5 spacer, then put it back in. So now I've got a 0.5 spacer. So if I added a 0.5 spacer and it read that, what would we have? Do you understand what I did? I can't show you on this picture and it's out here, but I
0.325.
I basically added a thing right here that said 0.5 on it.
Oh, so
Just 0.5.
So it'd be 0.775.
So we have 0.2, 0.075, and we have a 0.5. So 0.7. So it's, and also it's 2 inches. So 2.775. 2.775. Okay. So you can add the little spacers. So again, if you get confused, here's one that adds a 1 on it. So you can take that off. Jeez. Take off this end piece. So let's screw this on. And it starts becoming more and more complicated. I got a 1 inch on the other side, so now it's 3 point. So you can get kind of complicated. The problem I've always had with these is that with something like this, I can calibrate it every day if I want to. Something like this, they don't make standards for it. You've got to use a calibrated micrometer, then turn around and do this. So to be very honest with you, in my shop, I never read these. Never, never, ever. I just use it as an adjustable screw. Got it where I wanted it, turned it around, put it inside of a calibrated micrometer, read what the micrometer said, that's what that says now. And I don't have a problem if you do that. It's however you want to do it. Did you understand what I said? So if you don't want to read direct off this and it confuses you, then don't. Put it in a micrometer. Do not put the micrometers in a vise. I've said it now. Please, don't do that.
Would there ever be a reason?
Every freaking class.
Put micrometer in vice, okay.
Yeah.
Oh boy.
Which end do they put in the vise, though?
The insulated handle.
I can see that.
Yeah.
So that you have
So-
to disable micrometer.
You know, why do students do half the crap that they do? I don't know. Because it's hard. If I had to measure this right here, how am I need a third hand. I don't. I just do it like this. Just rest it on my big old, and just do it like this. Hold it like that. They do make micrometer holders. I was going to buy a bunch. I just can only buy so much. I only get so much money, and so I didn't. And I know, and I come around. I'm like, and you'll hear. I can get rather loud when somebody does stuff like that. Like, why are you doing that? And everybody stops and looks and like, okay, that was loud, huh? And you know, the answer is like, I've got a rag. I barely tightened it. It just looks so bad. So, yeah.
They kind of look like handheld riveting tools. The micrometer set kind of looks like a riveting tool we used to use in our shop. It's like, and we would always put that in a vise and cinch it down so we could hold it.
Oh, the riveting tool.
Yes.
Yes, of course. The
So I
squeezers.
can see how somebody saw a riveting tool and saw that like, oh.
No, they just didn't want to do it. This also has a little thing on the side, just a little, and you can put this in. Hold it like that, so you can go down deep into something. So, all right, when you're using stuff like this, that's an appropriate, you know, hey Kevin, I'm using this, and I just, could you show me how some of these little pieces in the kit go together, please? Can you help me put it together? That's a very appropriate thing to ask. It's probably not appropriate to ask your neighbor who just saw one for the first time in their life, as you said, how does this work? So, yeah. All right, so that's inside micrometers. Inside micrometer. Let me see. Oh, I didn't write all my stuff. Let me see. We did all that. Using the micrometer. Do not put the micrometer in a vise. And I used 2 exclamation points, so I was loud. Use the clutch/ratchet. Calibrate often. Use the calibrated gauge blocker standard. Keep it clean. Do not store the 0 to 1 in a closed position. So when you put it away, the 0 to 1 should have some sort of airspace on it. And probably don't do that. So the reason why is because if you close it up and you have a temperature differential, then it's going to want to expand it and throw it out of calibration. So there we go. This is the, yes?
You said 0 to 1, is that different for others?
You're not going to get very close. It only moves an inch, so you can close these all the way up if you want. Show me how you did it.
With the vise.
All right, what is this one called?
Dial caliper.
Dial caliper. These are so easy to read. Do we use these for return to service?
No.
They are used for
Reference.
reference. So right there is that right there is 1 inch, 1.1, 1.2, 1.3, 1.4. 1.4, 5, 51, 52. So 1.4525 if you wanted. I said 8 that time, so. Do you see where I got that? So, and this is just, when this goes around all the way, it's going to go around between the 2 and the 3 here. Between the 4 and the 5 where it is, it's halfway, a little over halfway between the 4 and the 5. You can see the dial right here is a little bit more than halfway. Every one of these little lines is right there, 0.001. That's what it's telling you. Between the lines is 0.001 on the dial face. So that's 1 inch, 1.1, 2, 3, 4, 5. So it's 1 inch, 0.4, 5, 51, 52, 8. So 0.1, 4, 52, 8. 1.4, 52, 8. Got it? Now they make these in digital now.
Dang.
So you just close it, hit the on button, hit the 0 button, measure it, and read the dial. Read what it says. That's how you use that one. But again, I don't use these for return to service. Now, yeah.
If they bring a digital from home for the purpose of the measuring in this class, so if they're just using it for reference, you don't care if they bring it home?
You can't bring in a digital for this class
You don't want them to bring it home?
because I know exactly. I know my students.
Okay.
You use a digital, you will measure the thing that you're supposed to measure. You will write it down, and then you'll have this and go, oh, that's what that says. Okay. I'm aware.
I didn't even think of that till you said it.
Oh, I've had every kind of student there is. These measure 3 different things. They measure the outside diameter of something, the outside diameter of something. They will measure the inside diameter of something. Here we go. The inside diameter of something, right there, or the depth of something. There. So the depth of that is 1.115. It's on the 15, just past the 1. So three things in one. The dial caliper is the fun one. The vernier caliper is the exact same thing without the dial. It is not so fun to read. It's a little more difficult. But you can see right here, jaws for measuring inner diameters. There's the jaws for outside diameter, and there's the stem for measuring depth. I could have had that there a second ago. When this is laid out, it's a little more difficult to read, but it's the same thing. Sometimes I have to stop and take a look at where we're at. Okay. So we're going to read it right here on this 0 line. This is the spot where we're reading it from. And this is the veneer up here. This is the measuring down here. So the way it is, we can see that it's less than 1 inch because we're going to measure it right here at this 0 line. And that is before the 1. Yeah? Okay. So we've got 0.8. That's 2.5, 50, 75, 1. Same thing. So it's just like reading a micrometer. Each one of these is 0.25. So we have 0.8. We have 2 lines. So that makes it 0.5 right there. I wrote that down. And then, so it's 0.850. Does everybody see 850? Oops, bigger. 850? Okay. And some change. What is that change?
That's the veneer.
That's the veneer. And that's what these numbers up here are for. So which one lines up? Well, I circled it for you, so it's really easy. This lines up, which happens to be 12. So we look at add the 12. So 850, 12. Yes?
With the veneer, it's the largest number that lines up because you can have multiple that line up.
No, you'll never have multiple to line up.
Oh, because I see there's the one on
The
the 6
2.5.
that looks, or the sorry, 8
Oh.
that looks really close. And the 6 and the 8 actually.
They're not.
No.
They're close, but they're not. That's why I don't like it. It's too much. So,
And when you have one in your hand, it becomes clear.
actually, I need magnifying glasses to read those things. That's when you get a magnifying glass, you're like, oh, I see. Whew. All right. Inside micrometer, we did that. Dial veneer caliper, usually 0 to 6 inch. Veneer,
Are we going to be using veneers in class?
probably not this class. No. I don't even think I have a one for a dial caliper. Yeah.
Can I take a picture of that screen?
This one?
Yeah. It's the only one I've had
There's a
issues with.
copy of this one in the gift shop on the way out. You can buy that one. You can take a picture of anything you want. I don't care.
Oh, sorry, thank you.
Real nice teacher would just put these up in Canvas for you. But then you'd know what I'm going to talk about. Then you'd be bored right now. So I have to surprise you. Okay. These are T gauges. T gauges are an extremely crappy way to measure something exactly. Oh, it's got my pen sitting there. There we go. T gauge, T gauge. Got the veneer. Veneer. T gauge. Okay, T gauges. T gauges and ball gauges. T gauges suck. I won't use these unless I absolutely have to, and I only will use the smaller ones. So if you have to measure the inside diameter of a hole, and I just happen to have something here with an inside diameter right there, right? Then my preferred tool would be to use a ball gauge. And I put that in there, and I'm like, oh, man, the ball gauge is really, you can see it right there, goes up to 1/2 inch. And that's a test question, I think, in your Q&As at least. What's the biggest size of a ball gauge? And it's 1/2 inch. So if you had to measure something, an inside diameter hole that's more than 1/2 inch, you would have to use a T gauge. So I would be okay with that, me personally, T gauge. So I'm going to get a small T gauge. And the way the T gauges work, I'll use a big one so you can kind of see it, is when you squeeze these down and you gently tighten this just enough so it doesn't work, it holds it in, then it'll hold it in. Then you put it inside of some sort of cylinder and you release it and it'll come out so far, then you lock it in, you pull it out, and you measure it with a micrometer. That's how you measure this. All right, so measuring something like this would not be a problem. Push them in, that, open it up, lock it, pull it out, measure it, right? So that's the way that would work. Actually, that's tapered. It wouldn't work well. So anyway, that's how that would work. So if it's more than 1/2 inch, I have to use a
T gauge.
T gauge. Let me see if I have something now.
just say really quick, because I'm the one that has to fix these. When it is tightened, and then you pull it out, you measure it, and then you're gonna release it, don't just release it, put your hand on it, release it, gently do it out, and then leave it kind of loose. You wanna store it that way, don't let it pop out, because then sometimes it'll just shoot off, and then you need to come see me, and then we gotta fix it. And so just, these are so finicky. Don't try to, make sure they're loose when you're measuring and then tighten. I mean, just pay attention when you're doing these, because they're very finicky. And
Okay, so if I wanted to measure the inside of this cylinder, this is what I don't like. That's not good for it. Don't snap it. All right, try to be gentle with them, as like she was saying. I really can't overemphasize that. And try not to let them fly out. If you open it up and let them fly out, there's a really good chance this is going to shoot out with a couple of springs, and you will look for it till you find it. And it'll take you maybe an hour or two. You'll just keep on looking. I'm like, I can't find the spring. Well, it's in here. Keep looking. So,
Gotta be ATAF.
yeah. Huh?
Gotta be ATAF.
I don't
All
know.
tools accounted for.
Okay. This is hard to explain, but when you're measuring something, this is a cylinder off of an aircraft. When you're measuring something, and I will have you measuring cylinders, the hard part is you have to think in 3 dimensions. Hard part's trying to find a place to set this down so you can see what I'm doing. Hold it all at the same time. We should have somebody just come here and hold it. Huh? Oh, I might have you. Because you can't see it there. I got my computer in the way there. All right, we'll just do the best I can. So if I put it in and I have it crooked, I'll try it this way. Need one more thing in there. It was there. Got to go around the horn. There we go. All right. It's going to come as a shock to you, but I'm a terrible drawer. So I have my cylinder right here. Here's the flange. So it's sitting like this. Here's the opening. Here's the flange. I like to know where the flange is because I like to measure it at the flange, and I'll explain why in probably a different class how all that works. But anyway, I've got to measure that. I have to measure it exactly between here and here. If I have it going like this, that is not going to be the correct measurement. Now, is it? It is going to be measured way too big. So, number one, it's got to be that way. Number two, I've got to measure it directly across that perfect circle. If I don't have it directly across that circle, and I'm measuring it this way, I'm exaggerating a little bit, it's going to be too small. So you have to have it in the correct plane in both dimensions. That is very difficult to do with a T gauge. It is, I shouldn't say it's nearly impossible. It's just hard. The best I can tell you to do, and I hope you can see this, is I anchor one point and have it crooked on purpose. And can you guys see this at all? Or is it
Yeah.
screen? And I doubt this box is strong enough. Better?
Yes.
Yeah.
Okay. So I start with it crooked. I'm going to anchor this next to me, pull it up until it looks like both points are exactly on the points of the flange. And by pulling it up, it tends to center itself this way, and you just stop when it gets straight up and down. And then lock it in, and then pull it out. All right? And then what I do is I'll anchor it on one end, and then go back through the cylinder. And it should be, it won't go, you'll go back and forth until there's a sweet spot where it goes through. It just drags a little bit. Because if you think about how that circle looks, going back and forth, too small, too small, too small, right? Either side would be too small, but right in the middle is perfect. And you kind of go back and forth at one little spot, it'll just drag through and then get loose again. And if you can do that, it's fine. Now, if you go back and forth and get stuck, then you've got this open too far. if you can go through and not even touch the cylinder, this is too small. So it's honestly, people do it, and you can do it. It's just, to me, that's not accurate at all. But that's what they're designed to do. And then, of course, you use a micrometer. For me, and I'm going to teach you how to do this in the engines class. It's just we can't do everything in this class. My preferred tool is going to be an inside micrometer. So I'll use an inside micrometer to do that exact same maneuver, but I can control it. I can squeeze it in a little bit. If it gets stuck, I can turn it in a little bit until I find that one little spot, and I go back and forth. I'm like, oh, that is so perfect right there. Take it out, measure it with a micrometer, and it's like, I'm done. Then I'll set it up for a bore gauge, which has to be calibrated to what you're doing. I'll show you bore gauges in a different class, and then you're good. So for this class, I'm going to have you practice using these to get a measurement, and then I'll just kind of check your work, see if I get close. If you're close, I'm pretty lenient on that. But do your best. But you're also going to be measuring guides. I have the valves in here so you can't see the guides. On cylinders, we have an exhaust port and an intake port. And so you're going to be asked to measure the intake and exhaust port on the cylinder. It looks just like this. So exhaust ports are identified, they have more fins. They're hotter, also round. So this is the exhaust side, this is the intake side. The intake side doesn't have as many fins. So, but it's in a drawing, you'll see that. So there we go. T gauges. They suck. T gauges, ball gauges. What's the most you can measure with a ball gauge? Half inch. After that, you must use a T gauge. Don't snap the T gauges, and don't let things fly around. Be nice to them. Oh, that's why that piece of tape is there. All right.
Exhaust has the most?
Huh?
Exhaust has the most?
Yeah. It's the hottest. So it has the most fins. This is a dial indicator. You won't be using it, but I just thought I'd bring one in, a dial indicator. They are also fragile. These little pieces on the side are made of plastic, and since all of you are extremely strong, you like to until everything cracks, and then we have to buy new ones. So it has a magnetic base on it. This magnet appears to be broken since it won't stick to my table. It's not a metal table, so that's the joke. But you use this to measure something that is has run out. So, like I talked about the story yesterday with the flange, with the guys and the stump and the sledgehammer. So I put a crankshaft in V blocks and I'd hold it and turn the crankshaft around. The flange would wobble this way. Well, I would just put one of these up against it, and as it wobbles, it'll push on this and make the dial move. So, dial indicator, which we will get into in another class, just so you know what it is. Let me see. Oh, I have this. Veneer, T gauge. T gauge, sometimes called a telescoping gauge. What is it used to measure? Inside diameter. These are all the things I didn't write. Usually comes in a set of 4 or more. About the smallest hole it can measure be about how much? About half an inch. And what's the biggest a ball gauge will go? Half an inch. All right, so that. Bore gauge for the guys. Okay. I'll just show it to you since we got it. What's in here? Oh. Depth micrometers. We'll be using depth micrometers when we work on carburetors. So it's just got a little plunger that comes out. So when it's flush, everything should be at 0. And as you turn it down, it's going to put that little plunger out. You measure it, and it's going to read it just like a regular micrometer. So those are easy to do.
And does that also have extensions on it like the inside micrometer would, or no?
They do, yeah. Okay, let me see. Ball gauge. Going through my notes, make sure I did it right. Ball gauge, similar to T gauge in function, but for what? What are these ball gauges for? Small holes. Down to, or up to half an inch. Let me see. You can use these things, and it's kind of an advanced thought here. You can use them as a go, no-go gauge. I'll write that down. Go, no-go.
And this is for the ball gauge?
Anything, ball gauge, T gauge. So let's just say I have a hole and a guide or a bore or something, and the manufacturer says it must be 0.475 to 4.478. It's got to be between those two. So I could do that one of two ways. I could take a ball gauge and I could stick it down in there, and I'm going to turn this, and it expands the little ball out, and the ball sticks, and I pull. It gets tough to move. It'll hold on its own. I'll pull it out, and then I'll measure it with a 0 to 1, and I could then write down the measurement. Or I could take a micrometer, a 0 to 1, and set it on 0.478. Follow me so far? Mm-hmm. So I set this at 478, and then expand the ball till it just fits in there, so the ball is 0.478. Follow? Mm-hmm. And then if it drops in the hole is
Too big.
it's a no-go. Do I care what it is?
No.
Do not. Bad is bad. So it's more than 478, throw it out. So that way it saves you time. So like if you had to do 6 cylinders or 4 cylinders, you're measuring a whole bunch of something, just set it up as a go, no-go gauge. Now the trick to that is you set it up, you're like pass, fail, fail, pass, fail. At the last one, I pick up the micrometer and I double check and make sure it's still at 478. So whenever you have tools like that, I always check at the last one. Yeah, it's still at 4, or it's still where I set it. Sometimes you get all the way done, you're like, I bumped it or I moved it or something. So anyway, that's setting up a go, no-go, which I can explain more in engines how to do that. But it's just a concept you should think about. If it's a fail, you don't care. You don't care what the number is. It just failed. All right. Other tools that you might be using. Oh, we have the bore gauge. That's a very complicated tool to use, but I like it. I don't think we'll, if we do it, I'll do a demo in class. Feeler gauges, which we won't use in this class. Let me see what we got. Okay. In the project that you're going to be asked to do in lab, you're going to be looking at a crankshaft that's very similar to this, and I've labeled it for you. Notice that the 1 is in the back, then it's 2, then 3, then 4. That's a Continental, even though a very astute person would know that's actually a Lycoming crankshaft labeled like it is a Continental, but that's because it's a nice picture. And you will be measuring and writing stuff down here. There are a couple of things that you need to be aware of. Nomenclature. There's a thing called out of round. Out of round. And if we look at this picture here, it's going to ask for, do I ask you to do out of round? Yes, I do right there. Okay. So you can see on here, it says, what is the front main journal and what is the out of round? You follow? So here's the front main journal. And actually, there's 2 of them. There's front main journal and then there's front main journal. There's one over here and there's one over here. I think, do I ask you? I only ask you to take one measurement. And this really isn't an exercise of trying to return a crankshaft to service or not. It's really more of an exercise in this class of, can you measure something? So I'm not going to be all concerned about where you measured it. I'll just ask you where you did. You'll measure it, and I'll measure it in the exact same spot. So whatever you do is what I'm going to do. There are holes in these crankshafts, right about where my pointer is. Right there is one. Right there I'm pointing to another one. There's another one on top here. There's the oil holes. Don't measure next to the oil holes. Number 1, they kind of curve in a little bit. Number 2, you get the micrometer stuck in an oil hole. So stay away from the oil holes. So here we go. So if we look at this, and I don't know, can you see that okay? Mm-hmm. All right, so it says front main journal. It should be 1.8720 is new minimum, and new maximum is 1.873. So anywhere between the 872 and 873 is a new crankshaft. Doesn't mean it's new, it means it measures new limits. Service maximum is the most it can be. Now, if it measures between the new on all of these, is that an overhaul or rebuild? There we go. If it's service maximum, but it's in service, then it has to be called
Overall.
except everybody calls it a overhaul anyway. But that is a part within new, serviceable, or outer limits. So we take our micrometer and we measure it. Let's see, we have a circle. And we measure it in this diameter. And let's say in that one right there, we get a measurement of 1.87, let me see. We'll go 872. 1.872. Is that new, serviceable, or out of limits? New. Now remember, this is a circle. Is it going to wear bigger or smaller?
Smaller.
Smaller. But if it was the bearings, they're going to wear bigger. So, all right. So that way is 872, and we measure it this way, and we get 1.8725. Okay. Let's get rid of that. What if it's 1.8715? Yeah, but well, wait a minute. Okay, let's go back to 8715. Is that okay? Let's go over here. Maybe you can see it. So we have 873 is as big as it's going to be. Then it's going to wear to 872, right? What's next? 871, 870. Anything in here is new. And from here to here is serviceable. So 1.5 is that's kind of right about here on the chart, right? So 8715 is serviceable. 872 is new. So is this? Is it new or is it? So I'm asking what the front main journal is. Is that and that's what that is. Is it new or serviceable?
Serviceable.
Why is it not new? I got 872.
Lowest measurement.
Worst case scenario wins. The way I did it in the shop is I would write measure it. I put 1.8715. In my out of round, I would put plus 0.0005. Okay, that was a code to me because out of round is the difference between those two. So it's 872 minus 8715 is my out of round. And you try and do that 90 degrees apart from each other. Technically, it'd be the biggest versus the smallest. So you could spend a lot of time trying to find the biggest and the smallest. I just do it in two planes. It's all right. You're getting a good picture. All right, but I always put the plus right there, that little plus. That was code to me in the shop that my outer round got bigger by half. So I always wrote worst case right there, worst case, went into my what is it, and then my out of round was always represented the bigger number. It's just how I do things. That way I'm always looking at the worst case number, and I never accidentally looked at this and go, oh, look at that, 872. Well, it's in new limits. I would look at it and go, no, it's 8715, which is right there, be serviceable. And, okay, what about this 0.0005, half a thou? Is that new or service limits?
New.
Okay, that's new. That's within new limits. Follow? Okay, so that's the difference between two things. And that's all you're going to do on each one of these items.
And
Yes?
We'd still put the out of round as new limits, even though the front main journal is only serviceable?
Yes, each one of these blocks is asking about that measurement.
Okay.
So that, and so, yeah, if I got 1.8725, that is new. And then if my out around here is 0.0006, that is serviceable.
Oh, yeah.
So each line, you're going to answer the question. Yes.
So 0.0005 is half a thou?
Yes. Because 001.0, hang on. .001 is 1,000, right? Half of that, so if I divided that by 2, it'd be .0005. 1/2 of 1,000, because 0005 and 0005 equals 001. So I say half a thou. All right. That cover measuring. That covers measuring. I will likely interrupt you several times in the lab. Please don't take this the wrong way. And if anybody's like super shy, let me know privately. Just go ham when they're shy people, and I'll try and like give you a little extra room. But if you're not shy, and don't think that if somebody's doing something and I'm like stop them and I'm like, okay, everybody gather around. That person is not in trouble. It's just, okay, that person has got to a point where I know that there's a sticking problem with, or they have a really, really good question and I want everybody to hear what they've asked me because it's such a good question. So I do a lot of like, stop, let's talk about this as a class with students, and it's not saying that that's a bad student. So it's just a good moment to show everybody something or that I haven't thought of. So let's see. All right, questions for me?
So on the measuring.
Yes. I almost had no questions.
Sorry. You logged the minimum and then the out of round. Would there ever be an opportunity for the out of round to be below that minimum?
Oh, okay. So yeah, a good question. So let me see. Do I have that? Here. So we're going back to here. So you're saying that you want to stick with the 1.872 here?
Well, like on the basically on the second measurement there.
Okay.
Your main.
So we'll take this one right here, and we got 1.87. No, 1.869. 1.869. So 1.869 is that new serviceable out of limits. So this one is out of limits. OOL, out of limits. So what does that make my out around? Geez, that's a lot. 872. So that's what? How much is that? 0.8. Geez. 0.872 minus 0.869. That's all 3,000ths. Yeah, 3,000. So my out of round, and this is 0.003.
In the positive, right?
It got positive 8,003. So on my chart, jeez, stop it. Clean this up.
I guess I was just wondering, would there ever be an opportunity or a reason to make the out of rounds in the negative?
Oh, not in this case, but if I were measuring the inside of something, like the connecting rod that goes on that, then yes. So if I were measuring the inside of something, then I would do the exact opposite. The biggest dimension is the worst case. That's the most wore, because inside of a circle, it's going to wear bigger. So I'm going to write the bigger number there, and then my out of round would be negative. So this way was a little bit better. Hope you guys followed that one.
Yeah.
Which would be the case with something like this. So if I measured it this way, and it's 4.125, and I measure it this way, and it's 4.123, which number do I write?
4.125.
125, that's my biggest, that's the worst. And then, then my out around is negative
0.002.
2. Yeah, there you go.
Cool.
All right. All right, that's all we've got. Don't go away mad, just go away. I'll meet you guys on the other side of the street, where we will have lab. Another question?
Yeah,